Alright people, so here we go with 2.6, rational functions and their graphs. So we're going to continue on. It's going to be similar to when we were graphing polynomial functions in the last stuff. We're going to start by talking about domain, which we've done all year, and then we'll talk about the difference between vertical asymptotes and holes. We'll talk about how we find horizontal and oblique asymptotes, and then finally the steps needed to graph a rational function. So first piece, a rational function is going to be a quotient of two polynomials like p of x over q of x. And how we find the domain of a rational function. Remember, what affects domain is two things. We can't divide by 0, and we can't take a square root of a negative number. And really we should say an even index here, remember. So to determine the domain of a rational function, what we're going to do is set the denominator equal to 0, because that's going to be our biggest thing. Rational function is always going to have division. Set our denominator equal to 0, solve for x. And that'll tell us all the values that x cannot be. We won't have any square roots in this section, but if we did, we would also have to say those values have to be positive. But really, we're just going to worry about our denominator being equal to 0, set it equal to 0, and solve. So if we look at these here, we can just take our denominator, set it equal to 0, solve for x, we get 3, which means x cannot be 3. So you could say it is all real numbers except x cannot be 3. Now in our other one, this one can be kind of tricky. If we say x squared plus 9 equals 0, we'd end up with x squared equals negative 9. So in this case, since this can't happen without imaginary numbers, our domain is just going to be all real numbers. There are no numbers to exclude on this one. A vertical asymptote then. So vertical asymptotes and holes are going to have to do with our domain. So a vertical line, x equals a, as we approach, as x approaches a. Okay, so our graph is going to approach it from one side or the other or both sides as x approaches a. So a is just going to be some number. Okay, created by values that in the x of x that make the denominator 0. Okay, so this is going to come from our domain. Both of these come from domain values. Okay, now holes is just going to be a discontinuous point. It's the same idea in principle. The only difference, and this last one is the important piece, vertical asymptotes are only when the denominator is 0. Holes are when both the numerator and the denominator are 0. Okay, so that's going to be how you tell the difference between a hole and an asymptote. You're looking at your domain restrictions. Either one or both pieces is 0. Determine if there's a horizontal or oblique asymptote. We're going to have three different options here. Let n be the degree of the numerator and m be the degree of the denominator. If our numerator has a smaller degree than our denominator, then y is the horizontal asymptote. If they're equal, then y equals a sub n over b sub m. And what this means is your leading coefficient in the numerator, and this is going to be the leading coefficient and denominator. Okay, so this is just going to be some number. Remember, no x's there. It's just going to be the leading coefficients in the numerator over the denominator, and that'll be a horizontal asymptote. You can get an oblique asymptote, which is actually going to be like a diagonal line, not vertical, not horizontal, when m is greater than m. And the challenging part here is that we're going to have to do long division in order to figure out what your equation is. So your oblique asymptote is going to end up with some equation in slope-intercept form, y equals mx plus b, where this mx plus b is the answer to your long division. It doesn't matter if you have a remainder or not. We can just ignore that. You're just going to get mx plus b. So a couple examples here in this first one. You see the degree of the numerator is 2. The degree of the denominator is also 2. So since they're the same, your horizontal asymptote is going to be the leading coefficient of the numerator over the leading coefficient of the denominator, which is 1 here. So we would have a horizontal asymptote of y equals 4. Okay, on this second one, you see the degree of the numerator is 1, and the degree of the denominator is 2, which means your numerator is less than your denominator, so you would have a horizontal asymptote of y equals 0. Okay, if we switch these, we'd have to do long division to find out an oblique asymptote. So these are two examples of horizontal asymptotes. Okay, and then finally, how we're going to graph a rational function. So we're going to take a lot of the old stuff that we've already done and combine it with some of this stuff today. So you're going to start by finding your domain of the function. And in order to find that domain, you're going to need to factor. So you're going to use the domain, then those factors, to find the vertical asymptotes or holes. Remember, only the denominator is 0, or holes, both the numerator and the denominator are zeros. And then you're going to find your intercepts. So you're going to find your x-intercepts as well as your y-intercepts. Remember, x-intercepts is when the whole function equals 0, and really we can focus on that numerator in this case, and your y-intercepts is when we plug in 0. So you get f of 0, and that's going to give you your y-intercept. Okay, after we have that, we're going to determine our horizontal and oblique asymptotes. So this had to do with the degrees, whether we could do long division or not. And once we have that, we're going to determine where the graph is above and below the axis. And we'll talk about this in class tomorrow. But essentially, we're going to make regions using our domain and our x-intercepts, because those are the only places where we could switch from above the x-axis to below the x-axis, or vice versa. And finally, once we have all that information, we're just going to graph all points and asymptotes and connect in a smooth curve. You can use your calculator to check for this, but trust me, you're going to want to know how to do it by hand, because the calculator is not always going to be able to show you every detail that you're going to need to be able to show. So that is it. One of domain, which again, remember, we are talking about the denominator being 0, which has to do with our vertical asymptotes and holes as well. We're going to do long division for our horizontal and oblique asymptotes, and then we're going to put it all together to graph our function. See you next time.